Right now, you're doing something your brain makes feel completely effortless. You're turning a thought into sound. A thought that exists only inside your head becomes a sequence of tiny movements in your tongue, lips, throat, and vocal cords. Someone else hears those vibrations. And somehow, they reconstruct the thought. Not the sound, the meaning. They know what you meant. They can imagine the person you're describing. They can understand the joke. They can remember the story. You do this every day without thinking about how bizarre it actually is. But there was a time when none of this existed. No English, no Chinese, no Arabic, no word for tomorrow, no word for memory, no way to tell another human being, I know something you don't. So how did an ancient human with no alphabet, no dictionary, no grammar book, end up producing Shakespeare, mathematics, apologies, contracts, and bedtime stories? Nobody knows exactly. And that's what makes the story so strange. Language doesn't fossilize. A skeleton can survive for hundreds of thousands of years. A stone tool can survive almost indefinitely. But a sentence disappears the moment it is spoken. So researchers have to reconstruct the beginning of language from fragments. Bones, genes, brain anatomy, archaeology, and clues left behind by people who never knew they were leaving them. One of the strangest clues is about the size of a fingernail. A tiny horseshoe-shaped bone in your neck called the hyoid. You've probably never thought about it, but it anchors muscles involved in the movements of your tongue and throat that help make speech possible. In 1989, researchers recovered a Neanderthal hyoid from Kebara Cave in Israel. Its shape was remarkably similar to a modern human hyoid. That didn't prove Neanderthals were sitting around having conversations about philosophy. But it suggested something important. Their anatomy may have been capable of producing complex speech. And that makes the timeline uncomfortable. Because Neanderthals weren't primitive humans waiting for us to arrive. They were a separate branch of the human family tree. And if they possessed at least some of the physical machinery needed for speech, then the roots of language may reach much further back than our own species. But anatomy isn't language. A bone can tell you what a body was capable of. It can't tell you what that body actually said. That's where genetics enters the story. In 2001, researchers studying a British family with a severe inherited speech and language disorder identified mutations involving a gene called FOXP2. The gene became famous almost overnight. For a while, it was tempting to call it the language gene. But biology is rarely that simple. FOXP2 is involved in neural development, and the fine motor coordination speech requires not language by itself, but a piece of the machinery underneath it. Then geneticist Svante Pääbo, who would later win the Nobel Prize for his work sequencing ancient DNA, examined Neanderthal genomes and found something startling. Neanderthals carried a version of FOXP2 nearly identical to modern humans, which means some of the biological foundation for speech was already in place hundreds of thousands of years before writing, before agriculture, before civilization. Not proof of language, but another piece of evidence pointing backward, further than we'd expect. So the hardware may be ancient, but hardware doesn't explain why any of this evolved. Why would a species need something this complicated? One answer begins somewhere surprisingly ordinary: grooming. Anthropologist Robin Dunbar noticed something about primates. Grooming isn't merely hygiene, it's social. It builds trust, maintains alliances, strengthens relationships. But grooming has a problem. You can only groom one individual at a time. As human groups grew larger, Dunbar argued, physical grooming became an inefficient way to hold a whole community together. So maybe language became a kind of vocal grooming. You could talk to several people at once, gossip, tell stories, reassure someone, maintain relationships without ever touching them. In that view, language may not have started because our ancestors desperately needed nouns. It may have started because large social groups needed a better way to stay connected. It's an elegant idea, but it isn't the only one. Noam Chomsky approached the problem from almost the opposite direction, arguing that humans may possess an innate biological capacity for grammar itself, something he called universal grammar. In that view, children aren't building language completely from scratch. Their brains arrive already prepared with structures that make language learning possible. One theory emphasizes social pressure. The other emphasizes biological architecture. Truth may involve pieces of both, a brain built to find patterns, dropped into a social world that rewarded communicating well. Whatever the cause, at some point, communication crossed a threshold. First sounds, then meanings, then combinations of combinations. That last step changes everything. Because once you can combine a small number of meaningful units, you're no longer limited to a fixed set of signals. The animal is near the water. The animal that followed us yesterday is near the water. The animal that followed us yesterday is near the water because something scared it. Now you're not just naming things, you're describing relationships between things. You can talk about something that happened yesterday, something that might happen tomorrow, something that never happened at all. You can tell someone what another person believes. You can invent an imaginary world and invite someone else inside it. That may be the most important thing language gave us. Not the ability to make sounds, the ability to escape the present. So when do we actually start seeing evidence of a mind capable of all this? Roughly 300,000 years ago, Homo sapiens had already appeared, but the archaeological record doesn't show fully symbolic behavior right away. At sites like Blombos Cave in South Africa, researchers have found deliberately pierced shell beads and engraved pieces of ochre dating back 75,000 to 100,000 years, objects that seem to carry meaning beyond their physical function. Then, around 40,000 years ago, something remarkable happens in the record. A sudden surge of elaborate tools, detailed art, and complex burial practices, a shift some researchers call the creative explosion. Many suspect fully modern, grammatically complex language may have been the spark behind it. There was no single morning when one ancestor woke up and invented grammar. The change was almost certainly messier and more gradual than that. But eventually, something crossed a line. Humans weren't just surviving in the world anymore. They were building shared worlds inside one another's minds. Because that's the real consequence of language, not that it lets us communicate, but that it lets information outlive the person who discovered it. Imagine an early human figuring out how to make a particular tool. Without language, that knowledge is trapped inside imitation and demonstration. With language, you can describe it, teach it, improve it, explain why it works. And someone else can improve the improvement. Generation after generation, knowledge starts stacking. A warning can outlive the person who discovered the danger. A story can survive the person who first told it. A plan can coordinate people who have never met. Your great-grandparents could tell your grandparents could tell your parents could tell you, and you can tell someone who hasn't even been born yet. The information survives the person. And you're using that ability right now. Every sentence you're hearing is temporarily becoming part of your own thoughts. For the last few minutes, ideas that began in someone else's head have been reconstructed inside yours. You never had to meet them. You don't know what they were thinking when they wrote these words. And yet their thoughts reached you, across distance, across time, through nothing more than pressure waves moving through air. That's what you're doing whenever you speak. Not merely making noise. You're taking something invisible, a memory, an intention, an image, a question, compressing it into sound, and releasing it into another human brain. And somehow it works, so well that you almost never notice how impossible it is. So the next time you say something as simple as, "Remember that day, stop for a second," you're using a system assembled over hundreds of thousands of years. Ancient anatomy, ancient neural machinery, ancient social pressure. Generations of small changes that slowly turned meaningless sounds into symbols and symbols into shared thought. You didn't invent the sentence you're speaking, you inherited the ability to create it. And the person listening to you inherited the ability to understand it. Right now, you're doing something astonishing. You're turning thought into sound and sound back into thought. Two brains briefly sharing something that exists in neither one physically. And perhaps that's the strangest thing language ever accomplished. It didn't just give humans a way to talk about the world. It gave one human mind a way to enter another. If your brain just did something it never explained to you, subscribe.